Hi BC Calc students, it's me, your teacher. I'm making a video on improper integrals. So first of all, what is an improper integral? Well, when you first learned integration, you thought of an integral as the area. That's our interpretation for what the integral is. So an improper integral, it's just, it's when the area you're talking about is infinite in some way. So let me show you an example to show you what I mean. Here's the function y equals 1 over x. What if I asked you to integrate this function from 1 to infinity? Well, if you use this interpretation, where you're interpreting the integral as an area, well, we should start at 1, and we should go out to infinity, and we should look at the area under the curve. So I'm talking about this area. So this is a region in the xy plane, and this is an infinite region because the base is infinitely long. Now, just because the base goes on forever, that does not necessarily mean that the area is infinite. So the big question is the area infinite? For this example, the answer is yes, but I'm going to show you some other examples for which the answer is no. So let me show you the 3 examples I have for you right now. Here's the first example. Integrate from 3 to infinity 1 over x squared dx. So right here I have the graph of the function 1 over x. We're supposed to integrate this from 3, which is right here, all the way up to infinity, which is way off the page over there. So I'm talking about this region here. It goes on forever. So always, if you're given an improper integral, the very first thing to do is this. So I'll write the integral from 3 to infinity, 1 over x squared dx. I replace infinity with a letter, say b, and I write this as limit as b approaches infinity of the integral from 3 up to b of 1 over x squared dx. Okay, the next step is now just to do the integral like you're used to. So I need an antiderivative for 1 over x squared. Well, it's probably easier to write that as x to the power minus 2, because now you can use the power rule. Okay, so when I take the antiderivative, I'm using the fundamental theorem. I want to keep that limit as b goes to infinity in front of every line. Okay, the antiderivative is x to the minus 1 divided by minus 1. I'm evaluating this between 3 and b. Okay, so what does that mean? That means first I plug in b, keep that limit in front. I'll give myself some space. I'll plug in b, that gives me negative 1 over b. Check it. I plug in b. Now I'll subtract what I get when I plug in 3. That will be negative 1 over 3. Okay. So now let me think about what happens as b gets really big. So as b is getting bigger, 1 over b is getting smaller. It's getting so small, it's getting really close to 0, that in the limit it equals 0. So the answer is just, say 0 minus minus a third, in other words, 1/3. So that's the answer to this question. And because this is an infinite region, but we get a finite answer, we say that the integral converges. So an integral converges if you get some number out of it. Okay, let me give you another example. We'll integrate 1 divided by the square root of x from 1 to infinity. So the graph of this one looks something like this. Here's 1. I'm integrating this out to infinity, so I'm talking about this region. So it's pretty similar to the last question, the region in the previous question, but the function's a little bit different. This function is a little bit different from this one, so maybe something interesting will happen. Okay, so we have integral from 1 to infinity. I'll write it as x to the power 1/2 dx. First step, replace that infinity with a letter. We can use b again. Limit as b goes to infinity, integral from 1 to b, x to the minus half dx. Now, next step is I need an antiderivative. Antiderivative is x to the half divided by half. And I'm evaluating that between 1 and b. Okay, so this is equal to limit b approaches infinity. Now when I plug in b, I'll have 2 square root b. When I plug in 1, I will just have 2. Okay, now we want to think about what happens as b gets big. So if you pick a really big number, say 1,000,000, well, what's the square root of 1,000,000? That's 1,000. That's a pretty big number. If you pick an even bigger number for b, well, the square root of that is still a big number. So that means as b goes to infinity, so doesn't square root of b. So this limit actually equals infinity. What that means is that the curve, even though it's approaching the x-axis, it's not pinching down quickly enough, and this infinite region has an infinite area. So what we say in this case is that the integral diverges. So you diverge if you do not approach a finite number. In other words, you might approach infinity, or the limit might be d and e in some other way. Okay, I've got one more example for you, then we're done. Here's an improper integral because we have the infinity here. So we're integrating from 0 to infinity x e to the minus x dx. First step, we always want to replace the infinity with a b or some other letter. Integrate from 0 to b x e to the minus x dx. Okay, now we actually need to do the integration. We need to take the antiderivative. How do we do this? IBP. We have one function, x, times another function, e to the minus x. So in this case, I want to let u be x. So u prime is 1. I want to let my v prime be e to the minus x. Then my v is minus e to the minus x. Okay, so I want to use the integration by parts formula, which I'll write over here. It says the integral of uv prime should be equal to uv minus the integral of u prime v. So I'll use this formula in this example. So this is limit b goes to infinity. Give myself plenty of room. uv, so that's negative x e to the minus x. Now, because this is a definite integral, I want to evaluate this between 0 and b. Minus the integral of, let's see, u prime, which is 1, times v, which is minus e to the minus x. So I have minus e to the minus x dx in there. This is going between 0 and b. Okay. So next step, I'll plug in b into here. So I have negative b e to the minus b. When I plug in 0, I just get 0, so I can ignore that term. Okay, now here, I need an antiderivative. Antiderivative of minus e to the minus x is just e to the minus x. So I get minus e to the minus x between 0 and b. Confusing because there's a lot of minus signs. Check it, I do not think I made a mistake. Okay, now I'll plug in b, I'll plug in 0, so I have limit b goes to infinity, negative b e to the minus b, minus, see, b e, or sorry, minus e to the minus b. When I plug in 0 into this piece, I get 1. Okay, so as b goes to infinity, e to the minus b, so e to a really big negative number, that gets close to 0. So this whole piece goes to 0. How about this one? So this one, limit as b goes to infinity, minus b over e to the b. I just rewrote e to the minus b as you're dividing by e to the b. We could use L'Hopital for this. So we have minus 1 over e to the b. And this approaches 0 again. So this whole piece goes to 0. But we still have that 1. So the answer is 1. Put it in a box. And because we get a number out of this, the integral converges.